So here we're looking at section 3.3, and our big question for today is for which of the theorems involving parallel lines, and we talked a lot about these in our last section, and transversals is the converse true. Okay, so our learning targets, first we're going to use the corresponding angles converse. We've used the corresponding angles theorem, so now we're going to use the converse. We're actually going to build parallel lines. It's really important in geometry that we know how to construct these things and not just use all the information we're given. Then we're going to be looking at proving some theorems about parallel lines, and finally using the transitive property of parallel lines. So first, that first learning target was our corresponding angles converse. And remember that corresponding angles, or if I have parallel lines and a transversal, the corresponding angles are on the same side of the transversal, but they're both either above or below the parallel lines. So the converse of this theorem is if two lines are cut by a transversal, and I know that the corresponding angles are the same, then I know that the lines are parallel. So right, we talked a lot before that we knew the lines were parallel, so what do we know about the angles? Well, now if I know I have this transversal and I know the angles are same, then I can prove that my lines are parallel. Okay, so I'm going to find the value of x that makes m and n parallel. Well, going from that converse, if these are going to be parallel, then the corresponding angles have to be congruent. And these two are corresponding because they're on the same side of the transversal and they're both above the lines that we're looking at. So I can set them equal to each other. So I can say my 3x plus 5 equals 65. So now I just have to solve for that x. So in order to do that, I subtract 5 from both sides. So 3x equals 60. Well, now I see I'm multiplying, so to undo that multiplying, I divide by 3. So x equals 20. So if my x value equals 20, then I know that these lines are parallel using that converse. So now here, I want you to really think about this number 1. So do I have enough information to say that these lines are parallel? And how do I know that? So now our construction. I'm going to walk you through these steps of constructing our parallel lines. Okay. So the first thing we have to do is come up with a line and then a point that's not on the line. So I first draw my line M and my point P. Then somewhere on M, I pick a point Q and I draw my line through that. So you'll see that as this red line QP. Okay. So the second step is I get my compass. And whenever we're doing constructions, we're going to need a ruler, so our straight edge, and then a compass are the two big things. So I've got these two. So now I draw some arcs. So I draw an arc that crosses both of my lines, and then I draw an arc through point P. Okay, the big thing is here I don't change my compass. I just leave it the same distance. Okay, so now I can draw an arc with my radius AB, right? So AB, I figure out that length using my compass, right? I put my compass at point A and I figure out where B is. Then I move my compass up here and I put it right there where the arc crossed my line here, and I make a little dash. So now I see I have a point P and I have where my two arcs connected, which is there. So let's actually go ahead and do this one. Okay, so now I've got both my ruler and my compass. So this might take me just a minute using this whiteboard. So I have my line and I have my point. We're going to call this my point P that is not on my line. So now I take my ruler and we go ahead and tilt it, and I go through my point P and any other point on the original line that I've drawn. Okay, so there's those two. So now I can get my ruler out of the way a little bit, and I'm going to be using my compass. So I can take my compass like this, and I put the point here, right where my two lines connect, and then I can draw my arc. So now I'm going to move my compass without changing any distance, put it on that point P, and draw my arc. Oh, wait, it's not drawing. There we go. Draw my arc. So now I take my compass back and I place it right here. And remember, we're labeling these points. So let's go ahead and label them. I'll label this one A, and I'll label this one B, and we'll label C. So now I'm going to move my compass back over and put that point on point A, and wrong way. We're going to slide this out. We're going to see, this is why this is more difficult to do on here. Doing this with a real compass is actually much easier. So let's come down here, and I see I'm not quite there. So right there, and I'm going to change colors just so that I can see this. So blue. So now I've measured this distance, right? So now I can move my entire compass by measuring this distance up to point C and put the edge on point C. Now that I'm at point C, without changing anything, I draw a little arc right there. So now you will see that I have 2 points. I have this point P, and I have where these two intercepted. So now I can take my ruler and I can connect those 2 points and draw my line. So I know for sure, because I've gone through these steps, that this blue line is parallel to this red line. Okay, so that's following the steps of that construction. So now here's some more of our theorems, right? And we've looked at these in the last section, but now we're going to look at the converse. Remember, so here we're looking at alternate interior angles. And remember that alternate interior angles are on opposite sides of the transversal and are in between the lines. So here with this converse, this tells me that if I have 2 lines cut by a transversal and the alternate interior angles are congruent, then I can prove that these lines are parallel. So something very similar here with my alternate exterior angles. If I have these 2 lines cut by a transversal and my alternate exterior are congruent, then I know for sure that they're parallel lines. So similar to is using that consecutive interior angles. And remember that when I have parallel lines, and I know that they're parallel, my consecutive interior angles are supplementary. So here with the converse, if I know that my consecutive interior angles are supplementary, then I can prove that these lines are parallel. So here I'm going to prove that if 2 lines are cut by my transversal, so that my alternate interior angles are congruent, then my lines are parallel. Okay, so let's look at this. So the information that I'm given, and I always start my proof with my given, is that angle 4 is congruent to angle 5. And I know that because of these dashes. My goal is to prove that G is parallel to H. So here's what I can do. I always start with my given information, which is that angle 4 is congruent to angle 5. Well, the other thing I know is that 4 and 1 are congruent because they're vertical angles. So I can write that as my next statement. So my angle 1 is congruent to angle 4 because of my vertical angles theorem. Well, I see that I have an angle 4 in both of these first 2 statements, so let's use the transitive property to get rid of that angle 4. So now I have angle 1 is congruent to angle 5, which is the transitive property. Well, so now I see I have angle 1 and angle 5, and these are corresponding angles, so I can use the corresponding angles converse to show that these are parallel. Okay, so I used the corresponding angles converse to show and to prove that the alternate interior angles made my lines parallel. Okay, so here's another proof. So in my diagram, R is parallel to S, and again I'm told that by these arrows. So angle 1 is congruent to 3. So I'm going to go ahead and mark that so that I can see that in my diagram as well. So I want to prove that P and Q are parallel as well. Okay, so we always need to kind of make our plan. So let's look at like one pair of parallel lines cut by a transversal first. So sometimes we're given much more information than we actually need. Okay, so I'm looking at 1 and 2. So I notice that 1 and 2, if we're looking at R and S, and we're told that those are parallel, R and S, 1 and 2 are going to be congruent because they are corresponding angles, right? So Q is my transversal here. So I know that they are congruent. So now if I look at this group over here, I can see that I have 2 and 3. So if 2 and 3 are congruent, they'd be alternate interior angles, then I know that P would be parallel to Q. Okay, so now I can actually see that I have a plan. So I need to prove that 2 and 3 are congruent in this case. So here's my givens, right, that R is S, so I know that 1 and 2 are congruent by my corresponding angles, which we said. Okay, so I also know that 1 and 3 are congruent because that was a given. So I also can say that 2 is congruent to 3 by my transitive property, right? Because I've got 1 is congruent to 2. I also know 1 is congruent to 3. Since this 1 is in both of these, I know that these 2 can also be set to be congruent by the transitive property. So I can use my alternate interior angles converse to prove that P and Q are parallel. So look at these, see what you can do with these problems, see how you think through them. So now we're going to be looking at the transitive property of parallel lines, okay? And the transitive property of parallel lines tells me that if two lines are parallel to the same line, then they're parallel to each other. So if I know that P and Q are parallel, and I know that Q and R are parallel, then I can for sure say that P and R are parallel as well. So let's look at this example. The flag of the United States has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. So for using this transitive property, we can just start at the top. Well, I know that stripe 1 is parallel to 2, and I know that 2 is parallel to 3. So using that transitive, here I'm going to write this. So 1 is parallel to stripe 2. Stripe 2 is parallel to stripe 3. So since this and this are the same, I can now say that stripe 1 is parallel to stripe 3. Well, I also know that stripe 3 is parallel to stripe 4 because I'm told that it's parallel to the one immediately below it. Since these are the same, I can now say that stripe 1 is parallel to stripe 4. And I can continue going on this way until I get all the way to the bottom. So using this transitive property, I can look at each little piece and then kind of simplify from there. So I want you to think about these ones, especially number 6. So look at what you know from the diagram and what can we then move and explain further from that diagram. So let's look at our learning targets. So first we use the corresponding angles converse. We figured out how to construct parallel lines. Now make sure that you can do this. If you need to borrow a compass or a ruler, just come see me. Then we're going to be proving some theorems about parallel lines, and we were actually able to use a 2-column proof and a paragraph proof. Here's where you can use whatever kind of proof you like. And then we looked at the transitive property of parallel lines. So now that we've worked on these learning targets, go ahead and work on your homework for this section.